Modern agriculture has consolidated to meet the immense calorie demands of a growing planet. Step inside a commercial poultry facility, and you're looking at tens of thousands of birds, a sea of white, living in a highly concentrated space. But that incredible efficiency creates an immediate biological tension. When you pack millions of hosts into a single environment, you tip the host-parasite balance in the pathogen's favor. Without constant intervention, a high-density house allows a single infectious agent to sweep through the flock in hours. That speed means the industry relies on a strict rule. You cannot wait for a bird to get sick to treat it. The economic margins in poultry farming are incredibly thin. Reactive medicine is too slow, too expensive, and often ineffective once a disease has taken hold. Protecting a modern broiler flock requires an engineered timeline of defense. It actually starts at day -21, before the chick is even hatched, and runs constantly until the bird reaches maturity around day 40. A modern farm operates as a biological clean room. Surviving that 40-day growth cycle relies entirely on an unbroken chain of preventative measures, where every single link has to hold. This diagram shows the very first line of defense, trans-ovarian transmission. Before the chick is even an embryo, the parent flock is heavily vaccinated. Those breeder hens then pack the yolk of the egg with maternal antibodies, providing the offspring an immediate immune system that protects it for its first few weeks of life. But those internal antibodies mean nothing if the physical vessel is breached. If the mother hen has even slight nutritional calcium deficiencies, she produces a porous eggshell. Environmental bacteria slip through microscopic gaps and infect the embryo before it begins to develop. To prevent surface pathogens from penetrating the shell, eggs undergo aggressive sanitation when they are gathered. Facilities use strict temperature controls to keep eggs from cooling too quickly and drawing bacteria inward, followed by intense chemical treatments like formaldehyde fumigation to sterilize the outer barrier. Raising a pathogen-free bird starts with the egg. If that initial biological capsule isn't perfectly sealed and chemically sterilized, the battle is lost before it begins. This schematic shows the macro defenses of a modern hatchery. Holding the highest concentration of vulnerable life, the facility is geographically isolated from other farms. Inside, it uses a strict one-way directional flow. Eggs enter on one side, move through incubation, and chicks exit the loadout area on the other, ensuring clean air and equipment never cross paths with hatch waste. Even with perfect traffic flow, the internal environment must be meticulously controlled. If cold eggs are moved into a warm, humid incubator, moisture condenses on the shells. This sweating creates a perfect breeding ground for bacterial blooms that can wipe out thousands of embryos in a single machine. To give chicks an immediate advantage, medicine is applied in mass. At 18 days of incubation, vaccines are often injected directly into the egg itself. Then, right after hatching, day-old chicks pass under specialized machines that deliver a fine mist spray or eye drop vaccination to protect their respiratory systems. The hatchery acts as a critical bridge where biological vulnerability is at its absolute peak. In this environment, total sterility is the only fail-safe against mass infection. Once the chicks arrive at the grow-out farm, the building itself acts as a shield. Modern windowless houses feature concrete aprons at every entrance. Rain and UV light naturally sanitize them, preventing workers and equipment from tracking soil-borne diseases directly from the dirt outside into the facility. Inside, the climate is tightly controlled to eliminate respiratory stress. Temperature and ventilation are constantly adjusted, while automated red feeders distribute nutrition evenly across the litter floor, ensuring birds don't have to crowd or compete to survive. To further eliminate risks, the industry has largely abandoned open water troughs. Enclosed nipple drinkers provide fresh, uncontaminated water directly to the bird. This stops birds from spilling water into the litter, which would otherwise create the damp conditions required for fungal growth and parasites. The physical architecture of the house functions as a primary medical device, engineered from the ground up to block the most common environmental threat vectors. No matter how advanced the building is, human workers remain the most dangerous vector for disease. To step inside, personnel must navigate strict footbath protocols and wear dedicated biosuits. Farms also rely on an all-in, all-out model. clearing the entire flock and sanitizing the building at the end of the cycle to permanently break pathogen life cycles. When environmental defenses need backup, farm managers will turn to active interventions. Breeder and layer flocks often receive inactivated vaccines, which require careful individual bird handling to deliver a subcutaneous or intramuscular injection. This triggers a strong immune response, creating long-lasting protection. When an active bacterial outbreak does occur, antibiotics are used, but under strict, judicious protocols. Veterinarians isolate the specific pathogen and apply narrow-spectrum therapy to target it directly. Antibiotics are an emergency medical tool, never a substitute for good management or hygiene. This diagram outlines another very critical defense: safe disposal. When mortality inevitably occurs, the biological loop must be closed securely. Farms rely on strict disposal methods, like controlled composting, to ensure pathogens from dead birds cannot leach back into the local environment. You can clearly see the required stratified layering technique here. By alternating specific volumes of manure, poultry carcasses, and straw, the composter creates a self-contained high-temperature reaction. This natural heat neutralizes infectious agents completely while breaking down the organic material. These active medical interventions and human biosecurity protocols serve a singular purpose. They are the final, critical backstops when the physical environment is inevitably challenged. Looking at the entire operation reveals a vast, highly secure, integrated biological system. The industry spends billions engineering advanced genetics and optimizing feed conversion rates. But all that science is useless without the daily, meticulous execution of basic disease prevention. The hygiene of the facility is mathematically equal to the genetics of the bird. Because beneath that incredible scale, the system is exceptionally fragile. A single skipped footbath, one reused insemination tube, or a temporary ventilation failure can introduce a virulent pathogen. Once inside, it triggers a catastrophic biological collapse, often leaving total farm depopulation as the only way to stop the spread. Sustaining the modern global food supply relies on an obsessive attention to the invisible, maintaining a flawless, unbroken chain of defense every single day.